Welcome to this tutorial. In this session, we show how to use the high-resolution land surface temperature service. Before we jump into the demonstration, let us summarize the key aspects of the service. The land surface temperature service provides thermal data at 30-meter spatial resolution for selected areas using advanced machine learning methods and established Earth observation products. It enhances applications like climate adaptation, urban planning, and infrastructure resilience by downscaling coarse thermal datasets. It combines coarse resolution data from Sentinel-3 with the high-resolution information from Landsat 8 and 9. The service provides three main functions, which represents the three steps of the workflow required for using the service. We start by creating our area of interest and registering the datasets we want to work with. This ensures that all relevant information is prepared and available for the upcoming steps. Next, we set up our user-defined on-demand pipeline runs. Here, we register each run and monitor its status, so we always have a clear overview of the processing progress. Once the pipelines are completed, we move on to exploring the results. We take a closer look both visually and through numerical inspection, allowing us to fully understand the output and the insights it provides. In the design of the service, the following terms are important to understand. These terms are used in several occasions when interacting with the services, as well as in the linked documentations. An area of interest defines the specific geographic region where land surface temperature information is needed. It serves as the spatial foundation for all processing that follows. A pipeline run represents a sequence of processing steps that generates the land surface temperature product for the selected area, according to the user-defined time period. A dataset is linked with an area of interest and stores the resulting data cube containing all land surface temperature outputs created by the pipeline runs. A place refers to a geographic entity, which is either a point or a user-defined area from which time series information can be requested and explored. The service is available for all registered user on the destination Earth platform. Hence, please register and start interacting with our service. We start now with the first step regarding the creation of new area of interests and datasets. When entering the service, the first tab called Create Datasets is activated. As a convenient feature, you can use the search field to navigate to your desired area of interest. Then a new area of interest, with a fixed size, can be placed on the map by using the drawing toolbar. After placing it, a pop-up will appear asking you to enter a name for the area of interest. This name must be unique for each user account. Once the name is provided, the area of interest can be registered by clicking the Register button. Whenever the registration is completed, the new area of interest becomes available as an admissible item for the dataset registration in Step 2. If needed, you can also delete any registered area of interest. To register a new dataset, select a registered area of interest. Then an auto-generated name for the new dataset appears, and you can adjust this name as needed. It is recommended to choose a name that is easy to recognize later. After selecting the area of interest, you can register a new dataset by clicking the Register button. Registering a new dataset involves several steps and represents an essential prerequisite for executing subsequent pipeline runs. Because the registration process takes several seconds, the system displays a loading state until it is completed. Once the registration process finished, an overview table lists all registered datasets. If needed, users can remove any of their own datasets using the Delete button. Now, we show how to register and monitor pipeline runs, which fill registered data sets with surface temperature information according to the requested temporal coverages. To register a pipeline run, select a registered dataset, as well as admissible start and end dates. Note that the temporal coverage of a pipeline run is limited. An identifier of a pipeline run is generated by the service and can be changed by the user. After that, register the pipeline run by clicking on the Register button, which adds the requests to the service processing queue. The table in Step 2 provides an overview of all completed and running pipeline runs. The table supports filtering for dataset, area of interest, or status of the pipeline run. Moreover, a refresh button allows receiving up-to-date information on existing pipeline runs, completed or pending. The deletion of a completed pipeline run does not delete the linked datasets, and just supports keeping relevant information inside the table. Start selecting a registered dataset. If the dataset contains at least one linked completed pipeline run, its stored information will become accessible. Once the dataset is loaded, you can use the slider to move through different timestamps of the land surface temperature map layer, and you can adjust the color map to make subtle differences in the data easier to see. Double-clicking anywhere on the map opens a pop-up showing the land surface temperature for that particular location. If needed, a dataset can be deleted using the Delete button, and the Refresh button allows you to check for updates in the datasets. Further numerical inspection is possible by defining geographic entities such as points or areas to request land surface temperature time series. Start by using the Draw toolbar to mark locations directly on the map. When placing, a pop-up appears asking to enter a name for that location. Once all desired places are set, click the Get Time Series button, which, upon request completion, result in a line chart showing the land surface temperature over time for each selected location. In this session, we have shown how to use the land surface temperature service. We hope that by integrating it into your workflow, you can gain deeper insights into surface temperature dynamics and support more informed environmental decision-making.